AOPS counting and probability 10.17. A point P is randomly chosen in the interior of the right triangle ABC, as shown in figure 10.11. What is the probability that the area of PBC is less than half the area of ABC? So if we look in this diagram, if we make D the midpoint of AC, if P is on DE and E is on AB and DE and CB are parallel, if P is on point D, the point P is on the line segment DE, and the area of the triangle is less than half, because the area of a triangle is base times height divided by 2. So if you want the area of PBC to be less than half of ABC, then we need the height of the triangle PBC to be less than half of the height of the triangle of height of AC. So if P is on DE, then the area of a triangle is less than half. So that's 3/4, because that's the area of this trapezoid. AOPS counting and probability 10.18. Triangle ABC is a 30, 60, 90 right triangle with the right angle at C, and ABC is 60 degrees and hypotenuse of length 2. Let B be a point chosen at random inside ABC and extend ray BP to hit side AC at D. What is the probability that BD is less than square root 2? So if this is the triangle ABC and angle ABC 60 degrees, so BAC is 30 degrees and ACB is 90 degrees. And if point P is inside the shaded area and BP extended meets at D, we want BD to be less than square root 2. So since this is a right triangle and we know that AB is equal to 2, that means AC is equal to square root 3 and BC is equal to 1, because it's a 30, 60, 90 right triangle. And if BD, since we want BD to be less than square root 2, if BD is equal to square root 2, then DC would be equal to square root 2 squared minus 1 squared using the hypotenuse theorem, because this is a right triangle, DCB is a right triangle, and this is the diagonal side, and this is the legs. This is the hypotenuse. So DC has to be equal to 1. So the area of DCB is 1 times 1 divided by 2, which is 1/2. And the area of ACB is 1 times square root 3 divided by 2, which is square root 3/2. So the probability of point P landing inside DCB is 1/2 over square root 3/2, which is square root 3/3. AOPS counting and probability 10.21. 3 points are selected randomly on the circumference of a circle. What is the probability that the triangle formed by these 3 points contains the center of a circle? So if these are the points A, B, and C, and the center is O, this is a circle. So the arc lengths have to be less than 180 degrees. So if we fix point A, B, and C have to be like this, and if this is the circle lied in a straight line. So here's A, B, and C, and this is the same. This A is the same point as this A because it's in a circle. So the probability that the triangle formed by these points contains the center of the circle is 1/4, because the arc lengths have to be less than 180 degrees to contain the center of the circle. So that's a 1/4 chance.